this episode, we take the ideas you have been building about context, functions, and operations, and we turn them into something engineers can actually use day after day: a security requirements baseline. A baseline is the agreed-upon set of security requirements for a system at a point in time, written clearly enough that people can implement them, test them, and confirm they are still being met as the system changes. Beginners sometimes imagine requirements as a pile of statements that live in a document and rarely affect real work, but a baseline is different because it is meant to be actionable and stable. It is actionable because engineers can trace each requirement to a design choice and a verification method, and it is stable because changes are managed intentionally rather than by accident. The phrase trace and validate is crucial because a requirement that cannot be traced tends to be ignored, and a requirement that cannot be validated tends to become wishful thinking. Our goal is to show how a baseline is structured conceptually, why it reduces confusion and rework, and how it becomes a living reference that holds security together as the system evolves. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with what makes a baseline different from a simple list of security best practices. Best practices are general suggestions, but a baseline is specific to your system's mission, assets, and environment. It tells you what must be true about the system, not what might be nice. It also avoids vague language that can be interpreted differently by different people because vague requirements lead to inconsistent implementations. For example, saying data must be protected is not enough, because one person might interpret that as encryption at rest, another might interpret it as access control, and a third might interpret it as both plus monitoring. A baseline requirement should be clear about what behavior is required, when it applies, and what evidence will show it is being met. This clarity matters because security is often implemented by different people at different times, and a baseline helps them make consistent choices. Consistency reduces the number of hidden gaps and reduces the risk of accidental weakening over time. In other words, the baseline is a map of security intent that can be followed even when the original authors are not present. A traceable baseline starts by connecting requirements to the system security context you developed earlier. Each requirement should have a reason grounded in what the system is protecting and what threats or failures it must withstand. That does not mean every requirement needs a long essay, but it does mean that if someone challenges a requirement, you can point to the risk it addresses. This prevents a common failure pattern where a requirement is removed because it seems inconvenient, even though it was addressing a real and serious scenario. Traceability also helps with prioritization when trade-offs are needed, because you can see which requirements protect the most critical assets or reduce the most severe risks. Without traceability, prioritization becomes political or emotional, and security suffers. When requirements are anchored to context, teams can make decisions that are more objective and better aligned to mission. This is one of the most practical benefits of a baseline. It turns security debates into reasoned conversations. Next, a baseline should be organized in a way that matches how engineers build systems, so it is easy to find what applies to a given component or function. Requirements can be grouped by areas like identity and access, data protection, audit and accountability, system hardening, availability and recovery, and secure change management. The specific grouping is less important than the idea that the baseline should be navigable and that similar requirements should be written consistently. Consistency includes using the same terms for the same concepts, such as always using the same word for an identity type or always describing authorization in the same way. It also includes avoiding hidden exceptions that only the author understands. When a baseline is organized and consistent, engineers can apply it during design and implementation rather than only at the end. That reduces rework because they do not build something that later fails a requirement they did not know existed. For beginners, it is helpful to see that good requirements are a form of kindness to future engineers because they prevent surprises late in the process. Traceability also means that requirements are connected forward to design elements, meaning there is a clear link between what must be true and what is built to make it true. If a requirement says only authorized users can access their own records, then the design must include an authorization mechanism that enforces ownership rules. If a requirement says high-impact administrative actions must be recorded, then the design must include audit logging that captures who, what, when, and where in a protected way. If a requirement says sensitive data must be encrypted at rest, then the design must include where encryption occurs and how keys are managed. The baseline does not have to describe the full design, but it should be written so that each requirement clearly implies the kind of design decision needed. This helps engineers avoid implementing a requirement in a superficial way, such as encrypting data but leaving keys unprotected, or logging events but allowing logs to be altered. When requirements and design are connected, you can check whether the design truly satisfies the intent. Validation is the other half of the story, and it means you can gather evidence that the requirement is actually met in the system as built and operated. Validation is not only about testing in a lab. It can include inspections, reviews, monitoring evidence, and operational checks. A beginner mistake is to treat validation as one final test pass, but a real baseline expects that systems change, so validation must be repeatable. That is why requirements should be written in a way that makes validation possible. If a requirement is vague, it is hard to validate because you cannot prove what it means. If a requirement is specific, you can define what evidence demonstrates compliance, such as logs showing access decisions, records showing review of permissions, or monitoring that confirms secure communication is enforced. The baseline should encourage requirements that are verifiable, because verifiable requirements are the ones that survive real projects. When teams can validate a requirement, they can catch drift early and fix it before it becomes an incident. To understand drift, picture a system after launch. New features are added, new integrations appear, and old assumptions change, such as new user groups or new deployment environments. If the security requirements baseline is not maintained, the system can slowly move away from its intended security posture without anyone noticing. This is why a baseline is not merely written, it is managed. Managing a baseline means changes to requirements are deliberate, documented, and reviewed so that people understand what is being tightened or relaxed and why. It also means that when changes occur in the system, teams can check whether the existing requirements still apply and whether new requirements are needed. Without a managed baseline, security becomes reactive, responding only after problems appear. With a managed baseline, security becomes proactive because teams know what must remain true and can evaluate changes against that truth. For beginners, this is a valuable concept. Security is maintained by controlling change, not by hoping nothing changes. A traceable baseline also supports the idea of allocation, meaning you can determine which requirements apply to which parts of the system. Some requirements apply to the entire system, like having an incident response capability, while others apply only to certain components, like a database needing encryption at rest. If requirements are not allocated properly, engineers may apply them inconsistently, either over-applying them where they are unnecessary or under-applying them where they are critical. Allocation is easier when functions and operational workflows are already documented, because you can see where data is stored, where identities are verified, and where high-impact actions occur. This is why earlier work on system context and a security ConOps supports the baseline. The baseline becomes the system's security contract, and allocation is how you assign parts of that contract to the pieces that must fulfill it. When allocation is clear, teams can build with purpose rather than guessing, and reviewers can validate with clarity rather than arguing about interpretations. Another key aspect is handling conflicts and trade-offs within the baseline itself, because requirements can sometimes pull in different directions. For example, a system might need strong confidentiality controls, but it might also need high availability during emergencies. If encryption key services fail, the system might face a choice between being unavailable or operating in a degraded mode. A good baseline anticipates such tensions by defining safe fallback expectations, such as which functions can operate in degraded mode and which must fail closed. Similarly, audit logging requirements can conflict with privacy requirements if logs capture too much sensitive data, so the baseline should clarify what must be logged and what must be protected or minimized. These tensions are not signs of bad requirements. They are signs that security is about balancing properties under constraints. By acknowledging and resolving conflicts in the baseline, you reduce the chance that teams make inconsistent choices during implementation. Consistency under pressure is what prevents incidents. The baseline also has a teaching role, especially for new engineers, because it communicates what the organization considers non-negotiable for the system. If written well, it explains expectations in a way that helps engineers internalize security principles. It can remind them that authentication alone is not enough without authorization, that logs are only useful if they are protected, and that access controls must match real roles and functions. But the baseline should avoid becoming a textbook. It should remain focused on what must be true and how you will know it is true. The best baselines are short enough to be used and clear enough to be trusted. When a baseline becomes too long and vague, people stop reading it, and it loses its value. For beginners, the lesson is that security documentation has to be useful to the people doing the work, or it will be ignored. A baseline is successful when it guides behavior, not when it merely exists. As we conclude, remember that documenting a security requirements baseline is how you turn security intent into an operationally meaningful set of commitments. A baseline is system-specific, clear, and organized so engineers can apply it during design and implementation. Traceability ties each requirement back to security context and forward to design choices, so requirements are justified and implementable. Validation ensures requirements are not just words, but verifiable properties, so teams can detect drift and maintain security over time. Managing the baseline keeps security aligned with change, so new features and integrations do not quietly erode protections. When these pieces come together, security becomes less about last-minute checking and more about continuous, confident engineering. For a beginner, the best habit is to treat each requirement as a statement that must be explainable, buildable, and provable, because that is what makes it real. When requirements can be traced and validated, they stop being hopes and become the foundation for trustworthy systems.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.